So here with the bee swarm package, we are already showing and comparing distributions because you see the distribution of the points. Another way to show distributions is by using a histogram. That's what many people do if they need to show a distribution. The good side about histograms is that it's easy to interpret them. You can look at them and see, well, does it look normal? Not so much. So easy to interpret, but they're very, very dependent on the setting of the bins argument. So you make histograms in R by using the histogram geom. And what it will do is, or what it will show is, on the x-axis, you have your measurements, but they are binned. Yeah, they are divided into categories. And on the y-axis in a histogram, you always have the number of measurements that fall into such a bin. So you can see here that there are 2 measurements between 10 and 12. 1 measurement between 12 and 14, 7 measurements between 14 and 16, and so on. So this is how a histogram works. Now, and bins, this argument, defines the number of bins that you see here. So 12 groups here on this one. The default number of bins is 30, and always when you make a histogram with ggplot2, it will tell you, hey, default number of bins is 30. That might not be what you need. Yeah? And the choice of this bins argument, as you can see here at the bottom of the slide, greatly influences what the histogram looks like. So this is the default, so 30 bins for our baby's data. This is when I increase the number of bins. So here it looks nice, very nice, normal distribution. If I increase the number of bins, it doesn't look that nice anymore. Yeah? I get these peaks. Here I decrease the number of bins. So, and here you see it's even more symmetrical than it is here. So depending on what you choose here, you get a different view on your distribution. This can be misleading. Yeah. People often make these histograms, and on top of the histogram, they put these density curves, this thing, yeah, these lines that represent the distribution. Okay. If you want to add such a density curve, you have to make sure that what he is showing here along the y-axis is not a count, because then it will not work. So density curves assume that what you show here on the y-axis is a density, yeah, of a frequency, basically, instead of an actual absolute count. So how can you change this y-axis from count, which is the default, to a frequency, to a density? Well, here by setting this argument in the histogram geom. So you have to tell him y is equal to a density, and these dots need to be there. They need to be there. Y is equal to a density instead of the default count. And this has to go inside AES. Yeah. Because to calculate these densities, he needs access to the data. So he needs a mapping to the data to calculate them. Okay, and this is why there is an astatics function here. Okay. The density lines themselves are created by a density geom, another geom. Yeah. Again, when do you use them? When you want to show or compare distributions. So you make your histogram with this setting, yeah, so that it produces here densities along the y-axis instead of counts. So you make your histogram like this, and then you add to that histogram a density geom. And as always, there are a lot of arguments that you can set. For instance, you can color the line in red. That's what we do here. You can also leave out the histogram, as you can see here, and only plot the density. that will also work. When you want to show more than one distribution, this is much more clear, just showing the density curves instead of showing the histograms on top of each other. So then you just leave out the histogram geom and you only go for the density. And here is an example where you use alpha, so you make them transparent so you can see through them. That's what you do here. Okay, going back to the code. Good. Let's make a histogram. So I'm making a histogram of the cars data. Yeah. Inside the aesthetics, I say put gas usage along the x-axis. And you see there's no y here. Yeah, there's only one column here. That's normal because in a histogram, the y is already defined. It is a count or a density, but it's nothing in your data. Yeah, it's something that the geom has to generate itself. So only one column here that goes along the x-axis and no column that goes along the y-axis. Every time that you make a histogram, you see red text. It's not an error. It's just saying, hey, I use by default 30 bins. This might not be the ideal value for you. And it's not, as you can see here. So if you want to change, here we are. If you want to change the number of bins, this is the argument that you need to set, the bins argument. So the bins argument, when you scroll down, the value corresponds to the number of bins you want to use. So if here in this plot, I want to use 10 bins instead of 30, I set bins equal to 10. Inside the histogram geom. So it's one of the arguments of the histogram geom. So when I run this, there we go. I now have 10 bins and it looks completely different.